Yes. Yeah, good evening all. So myself, I'm Vijay. Like I hold 20 plus years of experience, which includes nearly 10 plus years of experience in Hadoop and Spark environment. As part of today's demo, I'll be covering the following topics. Like what is Apache Spark, why PySpark, need for PySpark, and the Spark implementing with Python or Scala, which is the better choice. PySpark features, real life usage of PySpark, PySpark job market, right? So before I go, what is the course content I'm going to discuss first? I'll brief you that second, right? So what is Apache Spark? Why PySpark? Need for PySpark? Real life usage, PySpark session context, parallelizing, repartition, broadcast variables, accumulators, PySpark RTD computations, operations on RTD, directed acyclic graph actions and transformations, steps in RTD computations, persistence options, memory only, memory underscore SCR only, disk only, PySpark core computation, fault tolerance, model in Spark, different ways of creating RTDs, increasing the number of partitions in Spark, groupings and aggregation, single grouping, multi-grouping, single aggregations, multiple aggregations, group by, reduce by, right, operations, various inbuilt actions and transformations of Spark, count by key, count by value, sort by key, zip function, union, distinct, inner, outer, Cartesian, co-group, PySpark SQL data frame, and working with data frame API, creating data frame to pandas, row class, select, collect with column renamed, variant filter, drop and drop duplicates, order by and sort, group by, join, UDF, map, flat map for each sample, pivot, partition by array type, map type, PySpark SQL functions, aggregate functions, window functions, date and timestamp functions, JSON functions, when expr lit, PySpark built-in functions. So various built-in functions of PySpark with many working examples. To timestamp, to date format, explode array contains map values, map keys, dense rank from JSON, right? PySpark external sources working with SQL statements, Spark and Hive integration, right? Spark and Hive integration, Spark and MySQL integration, working with CSV, JSON files, transformations, narrow and wide transformations, addition of new columns, dropping of columns, renaming columns, handling nulls, joins, handling nulls, window function, writing back to external sources, creation of tables, deployment modes, local mode, cluster mode, PySpark application, states and task drivers and executors, building Spark applications or pipelines, deploying PySpark applications to cluster and tuning, performance tuning, PySpark streaming concepts, integration with Kafka, PySpark ML right? So today, like PySpark has got a great boom in today's market, right? So if you can see the package also very huge packages for PySpark as compared with other technologies. All right. You can see the salary package 1.5 times the other technologies, right? In the same way, they'll be expecting the technical skills from your side. So in brief, in depth, we'll be discussing with many working examples. You will be getting the soft copy of these notes, clear notes of this. You'll be getting the recorded session of each and every one. Each and every session will be recorded and it will go for, it's a weekend batch, right? Saturdays and Sundays, you'll be having the classes only on Saturdays and Sundays. So 2 hours on Saturday, 2 hours on Sunday, 4 hours total. It will go for nearly 12 weekends. It goes in brief, in depth on this PySpark. Okay. You'll be getting that recorded videos, means each and every session video, classroom notes. A WhatsApp group will be created for technical discussions, assignments and tasks to work with. Right. Yes, just a second, right? Just a second. Apache Spark, it's an open source distributed cluster computing, right? So it's a distributed cluster computing framework. So distributed cluster computing means multiple systems. Data is going to be distributed across multiple systems and processed by multiple systems parallelly. Parallel process style. It's an open source distributed cluster computing with a parallel process style with in-memory computation used for large scale data processing. Used for large scale data processing. So observe, it is a general engine for big data analysis, for processing and for computation. In-memory computation, main thing what you see here in Spark, in-memory computation, storage and processing, everything happening within the memory level, that is within the RAM level, right? Everything happening within the RAM level. So distributed computing, parallel process style, and that too everything in the memory level storage and processing for large scale data processing. Spark was developed by Matei Zaharia in AMP lab. It was open sourced in 2010. Was donated to Apache Software Foundation in the year 2013. It was donated to Apache Software Foundation in the year 2013. Spark can be coded with multiple languages. You can code with Scala language, Python, Java, and R language. But Scala and Python are the mostly used currently, right? Previously, Scala was used a lot. Now, currently, Python is used a lot, right, for implementing Spark. Spark is an execution model implemented by using Python. So PySpark is a Python API for using Spark. PySpark, if you talk about PySpark, why PySpark, right? It is one of the lightning fast technology that is designed for fast computation. It's one of the demanding tool among the data engineers to work with bigger data sets. So it is used for what purposes? For running distributed SQL. So it's mainly designed for batch applications, for iterative algorithms. Batch applications means user non-interactive applications. User interactive applications we call as online applications. Batch application, user non-interactive applications. Iterative algorithms means most of these algorithms are iterative, means you can keep on applying again and again until the error becoming zero. For interactive queries, for SQL queries, and for streaming. So why PySpark, right? I said it's a Python API for using Spark. PySpark is used for running distributed SQL. PySpark is used for running distributed SQL, creating data pipelines, creating data pipelines, ingesting data into a database. PySpark is used for running distributed SQL, creating data pipelines, ingesting data into a database, machine learning algorithms used for ML algorithms, for graph algorithms, for data streams, and need for PySpark, right? Huge amount of data is getting generated everywhere, right? So this data contains hidden patterns, unknown corrections, market trends, customer preferences, other useful information. So it is necessary to extract the valuable information from this raw data. We require some efficient tools to perform this. So there are various tools available already, but they're not that much of appealing. So, but we require some scalable and flexible tools to crack big data and for gaining benefit from it. So combining Python and Spark, it's the very efficient for the world of big data. That's why Apache Spark community came up with a tool called PySpark, Python API for using Spark. So where it is, PySpark is 100 times faster than this normal Hadoop, big data Hadoop, right? It's 100 times faster. Python versus Scala, right? Which is mostly preferred. Python and Scala. Python is a interpreted dynamic type. Scala is statically typed. Means dynamically typed means if you are assigning a integer to it, a integer variable created dynamically. No need to define the data type. Assigning a float value to it, a float variable is created dynamically. Python is an open source and has a huge community, like 89,300 modules for every domain it is providing. But Scala has a community which is smaller than that Python. Python contains a powerful libraries for data science, graph, and streaming. Scala has got less. Python is slower than Scala. Scala is 10 times faster than Python. That's the only advantage you see on Scala. But Python has got a lot of other advantages. PySpark features, if you see, like in-memory computation, memory level storage and processing, lazy evolution, on-demand executing the flow. Means if you make an action only, then it will going to, otherwise it won't execute. Just like a function, if you make a call, then only the function executes. Fault tolerant. Spark has powerful fault tolerant model. So I'll be discussing in brief about this fault tolerance. Immutability. Spark objects are immutables. Changes and modifications can't be done on the original data. The original data won't be disturbed. It is immutable. Changes, modifications not allowed. And Spark data is divided into partitions, multiple partitionings we say, right? Spark data is divided into multiple partitions. They are distributed across multiple systems and is executed parallelly. Distributed execution. Persistence. Reusing the already executed transformation. Reusing the already executed, here no need to re-execute. Already executed transformations, we can reuse it. So these are the main features. Once again, I'll brief about all these things, right? Real life usages means in the commercial sector it is used. In healthcare it is used. In commercial sector, like the real-time, that is Apache Spark real-time processing. In bank and other financial fields, which uses Spark to retrieve that customer social media information or profile, help in taking the right decisions, in credit risk assessments, in fraud detections, in healthcare, identifying that who is going to face which patient is going to face the issue based on this medical reports. Entertainment industry, like the more popular OTT platform like Netflix using Apache Spark for personalized, for processing personalized online movies or web series, processing 450 billion events per day that are streamed over server-side applications. Trade in e-commerce, like e-commerce sites like Flipkart, Amazon, all this, they are using Spark for advertising, and other sites for enhanced customer experience and optimizing the overall performance. Even tourism industry using Apache Spark to advise millions of customers, comparing hundreds of tourism websites. Okay. So if I talk about how the Spark data objects, right? Yes. We call them as RDDs, resilient distributed data sets. Spark data objects we call as RTDs, resilient distributed data sets. RTDs are subdivided into partitions. They are subdivided into partitions. These partitions are distributed across multiple RAMs of multiple worker nodes, slave nodes. See, here we follow master-slave architecture, single master and multiple slaves. Party node cluster, we say. One will be the master, remaining all will be the slaves. Everything will be interconnected. So the Spark data, huge data object divided into partitions and distributed across multiple RAMs. RTD programming style is data flow. Data flow means sequence collection of pipes, means RDDs. A pipe is a data operation. A pipe is a data operation like loading the data, transforming data, filtering the data, grouping the data, merging the data, sorting the data. In Spark, data flow is executed in a sequence. In Spark, data flow is executed in a sequence, that is RTD by RTD, one after the another, with in-memory computing feature and persistence feature. Spark RTD is executed in sequence, one after the other in in-memory computing. But if a RTD has 30 partitions, Spark data object, if it has got these 30 partitions, can execute in parallel. See, RTD1, Spark data object, it will divide into P1, P2, P3 into multiple partitions. Once it is all the partitions are executed, computed, the output of this RTD will be given as input to the next RTD2. RTD2 output is given as input to the next RTD, RTD3. The output of one will be the input to the next. RTD4, the output of this will be collected finally. Means here RTD is divided into multiple partitions. These partitions data is distributed across multiple systems. See, RTD, it has got a bigger data. The two, these RTD partitions are stored in the RAMs of the systems. These partitions are distributed across multiple RAMs of multiple systems. When this RTD2 is ready and computed, collected the output of this, the first RTD and its partitions will be removed. And this RTD partitions, P1, P2, P3, everything will be distributed across multiple systems. When RTD3 is ready, RTD2 and its partitions, everything are going to be removed from the RAM. So because all the four RTDs cannot fit into the RAM, that much of RAM capacity, because everything happens within the RAM level, right? In memory computation. So what happens once RTD3 got the output and once RTD3 is computed, RTD2 gets removed from the RAM. When RTD4 it's ready and computed, RTD3 gets removed from the RAM. And when RTD4 is computed and the output of it is collected, this also gets removed from the RAM. Yes. These are going to get removed from the RAM. Now, no RTD in the RAM, you can trigger the next flow, next job, next execution, right? RTD's computation, you can check with this diagrams, right? Yes. Clear notes I have got, not a worry. there is an RTD like this, R1, R2, R3, R4, R5, R7, R1, R2, R3, R6, R8. See the first flow, R1, R2, R3, R4. The second flow is from R1, R2, R3, R5, R7, flow 2. Flow 3, R1, R2, R3, R6, R8. To execute any flow, action need to be performed. Action has to be performed. Executing the flow 1, right? R4 dot collect. Whenever I say R4 dot collect, see this first flow, the last RTD dot some collect means action. Perform some action, then this R1, R2, R3, and R4, this entire first flow is going to execute. First R1 gets loaded. R2. When R2 is ready and computed, R1 is removed. When R3 is ready, R2 gets removed. When R4 is ready, R3 is removed. Once the execution is finished, R4 also removed. No RTD in the RAM. Executing the flow 2. R1, R2, R3, R5, R7. Flow 2, R1, R2, R3, R5, R7. If I perform R7 dot action, then only the flow executes. Otherwise, it won't execute. R7 dot collect means it's one kind of action. So the execution starts from its root R1, R2, R3, R5, R7. When R2 is ready, R1 is removed. When R3 is ready, R2 will be removed. When R5 is ready, R3 removed. When R7 is ready, R5 removed from the RAM. When execution is completed, R7 also removed from the RAM. Now, no RTD in the RAM. Again, executing the flow, last flow. R1, R2, R3, R6, R8. R8 dot collect, I'm saying. So if you see R1, R2, R3, R6, R8. When R2 is ready, R1 removed. When R3 is ready, R2 is got removed. R6 is ready because these many RTDs won't fit into the RAM. If all these are loaded into the RAM, then the next RTDs can't be accommodated, right? So once RTD is computed, the previous one will be removed. Once R8 means this last one is ready and computed. When execution is completed, then R8 also is removed. But here every time in the three flows, the first three steps are common, R1, R2, R3, R1, R2, R3. But every time you are re-executing from the starting, re-executing from that starting. Every time you are re-executing from the beginning. Even though first flow, second flow, third flow. Here, the three flows, no RTDs remains in the RAM. But in all the above flows, flow is re-executing from the beginning. Even the first three steps are common. So to avoid this, we need to identify the RTD whose output is commonly used by multiple flows. Here R3 output is used by flow 1, R3 output is used by flow 2, R3 output is used by flow 3. So the RTD whose output is commonly used by multiple flows, persist it. So that it will be available in the RAM and provides output to multiple flows. R3 output is used by multiple flows, so persist. How will you persist? R3 dot RTD name dot persist. This is the way you persist. Now, if it is persisted, see this flow. Now, if it is persisted, right? Now, flow 1 execution. Whenever I say R4 dot collect, R1, R2, R3, R4, in this way it executes. But for the first flow, you won't see any. When R2 is ready, R1 removed from the RAM. When R3 is ready, R2 removed from the RAM. Here R3 is persisted. When R4 is ready, R3 won't be removed from the RAM. If we are persisting any RTD, that RTD won't be removed from the RAM. When execution is completed, R4 also removed from the RAM. Here R3 remains in the RAM. Observe this flow. Observe this flow to right. The last RTD, if we say collector, see the diagram parallelly. See the diagram parallelly in the flow to R7 dot collect. If I say R7 means this last one, it will check, okay, R7 input is what? R5. R5 input is what? R3. So R3 is available in the RAM, right? It is
Yes.
persisted.
Yes, sir.
So we can take its output. So we can take its output. No need to re-execute from the beginning. Understanding? No need to execute from the beginning. So the flow will be from R3 to R5 to R7, R3 to R5 to R7. No need to execute for the first R1, R2, R3. R3 is available in the RAM. It's already executed. That output you can take it and compute the remaining flows. Some steps are decreasing right here.
Yes, sir.
The advantage of persistence, understanding. Yes. So next in the third flow also, right? If you see the diagram, R8 dot collector. R8 input is R6. From where R6 input is R3. R3 is available. So don't go from the beginning. So the flow R3 to R6 to R8. The first R1, R2, R3 already they are computed. R3 output is taking, computing R6 and R8. When the execution is completed, R8 also removed. So in all the three flows, all three remains in the RAM. So whenever you persist any RTD, it is going to be available in the RAM. In all the above flows, if the flow executions are completed, still R3 remains in the RAM. Still R3 remains in the RAM. If R3 not required, you can forcefully unpersist by saying R3 dot unpersist. When session is closed or when server shutdowns, RTD will be unpersisted. Another way. So see this, what are the situations where RTD will be removed from the RAM? Whenever current RTD is computed, the previous RTD gets removed. When action or execution is completed, last RTD will be removed from the RAM. These are the situations where that RTDs will be removed from the RAM. What are the two ways to persist an RTD? RTD dot persist means it will be available in the RAM and provides it outputs to the other flows. RTD dot cache, another way of persisting in RTD cache. So the difference I'll be discussing between these two, RTD dot persist and RTD dot cache. What are the different ways to unpersist an RTD? Different ways to unpersist an RTD means forcefully unpersisting by saying RTD dot unpersist. Whenever the session is closed, the server shutdowns. Whenever the server shutdowns or whenever the session is closed. Generally, which RTDs will be persisted? The RTDs whose output is used by multiple flows. That RTDs will be persisted. What do you mean by persistence in Spark? Making the RTD available in the RAM even though the next RTD is ready, so that it can provide its executed output to various other flows. So rules in RTD persistence I'll be discussing. You need to follow some rules here. There are many rules we need to follow. Steps in RTD computation I'll be discussing. What do you mean by lazy evolution in Spark? Executing the flow on demand only by performing an action. If you're not performing any action, it won't execute. The features of Sparks we have discussed. Okay. For example, observe this. On a RTD, two types of operations can be performed. One is transformations you can perform. Second one is actions you can perform. Transformations, inbuilt transformations that are. No need to write any code. Inbuilt transformations of Sparks available. Second thing is actions. If action performed only, then your data flow executes. If you are not performing any action, your data flow won't execute. Spark is a data flow language. The output of one will be the input to the next one. Talk about the transformations, three types. Each element transformation. Like we have got functions like map and flat map. We'll be discussing this in the practical part. 1 lakh employees, adding 5,000 to the salaries of each employee as bonus. Okay. So like functions rtd.map, rtd.flatmap, all this, right? Yes. rtd.map, rtd.flatmap. One kind of transformation is each element transformation. The other kind of transformation, filter transformation, filtering based on condition. Filter based on product, filter based on city. This is also one kind of transformation. These are the functions we have got. An rtd.filter based on product, based on city, based on department number. Aggregated transformation, group by key, reduce by key, or this for kind of performing aggregations like sum, max, min. All this I'll be briefing you in the practical part. So that just remember mainly three types of transformations. Each element means whatever transformations you are applying will be applied to each and every employee. That is, we call each element transformation. Filtering based on particular city product. We talk about actions. When an action is performed on a RTD, when an action is performed on a RTD, then only the data flow will be executed. Data flow will be executed from the root RTD or from the persisted RTD. When an action is performed on RTD, then only the data flow will be executed. Data flow will be executed from the root RTD or from the persisted RTD. Some of these actions are collect is one action. Generally, your Spark data is divided into partitions distributed across multiple systems. Whenever you say collect the action, it is going to collect all the partitions of different slave machines into a client machine. So just what you should say, RTD dot collect. Entire data flow is going to get executed from the root RTD to the current RTD and collects all the partitions output. Count, okay, into how many partitions it is divided means into number of elements in an RTD. Take of n, takes first n number of elements in a RTD. Takes the first n number of elements. RTD dot take of 10 means taking the first 10 records. If partition 1 is having 5 records, it takes 5 records from partition 1, takes 5 records from partition 2. Save as text file, storing the result into a file. Okay, so as of now, just remember collect, count, take, save as text file. But we have got many actions I'll be discussing one by one. And we have got many transformations also. But one thing what you need to understand, if we perform transformation on a RTD, the result what we get is also a RTD, Spark object. Perform action on a RTD. If you perform transformation, okay, you will get the RTD only. But if I perform action, if you perform action on a RTD, the result is also the result is not a Spark object. If you perform action on a RTD, the result is not a Spark object. It will be local object, Python object. If you see, if you observe here, a flow, sc.text file, okay, RTD1, from RTD1, on the RTD1, if I perform some transformation, right, map transformation, mapping some 5,000 to the salaries of each employee, the output whatever get is an RTD2. Again, on RTD2, I'm performing some filtering based on city. The result RTD3 only for particular city data. RTD3, the result what you get is RTD3.
Again, transformation.
So on RTD3.map, we got RTD4. RTD4.group by, the result is RTD5. So if you perform all these are transformations, map, filter, group by. But if I'm performing an action like collect, you won't get an RTD. It's what? A Python object. So whenever you say this action only, then it will be starting execute from this root to this. This entire flow will be executed if you perform an action. If you keep on transforming, okay. But to make the entire flow to execute, an action has to be performed. Here, RES1 is not an RTD. It's not a Spark object. It's Python object. Here, the final result, RES1, is collected and stored in the client machine. These transformations and this RTD is stored at Spark cluster set and computed. You will have multiple machines, right, for running parallelly. So they are stored in that machines and computed, and they gets removed. How many RTDs? 5 you got. Where all the 5 RTDs are stored. When action is performed, like collect, one by one RTD is loaded into the RAM, and one by one RTD will be computed at RAM. One by one RTD will be removed from the RAM. They will be computed, they'll be loaded, they'll be computed, and they'll be removed from the RAM. Before action is performed, how many RTDs in the RAM? 0. After action is performed, how many RTDs in the RAM? 0 only, right? Because once the execution is completed, one by one RTD removed. Finally, there won't be any RTDs in the RAM, right?
Yes,
So
sir.
that you can trigger the next flow, the next job. Now try to, from the base on your understanding, right? Try to say steps in RTD computation. Steps in RTD computation. Step one.
Color.
Initially, RTD computations. Initially, all RTDs are just declared. Say all RTDs are just declared. They are not stored anywhere. We load them. We load and execute them. When we load and execute them on demand by performing an action, then only it is going to execute from the root to this current order. When action is performed on a RTD, flow execution, how it happens? Try to when action is performed, flow execution will yes, flow execution will start. From its root RTD, or available RTD in RAM. When action is performed, flow execution will start from its root RTD or from available RTD in the RAM. Step 2. During the flow execution, each RTD partitions will be loaded into RAMs, and computed in the RAM. RTDs will be loaded sequentially. RTDs will be loaded sequentially, one after the another, not all at a time. If all are loaded at a time, they can't be accommodated. So here RTDs will be loaded sequentially, one after the another. Step 3. Everyone try to respond. Once RTD computation is completed, what do you observe? Once RTD computation is finished,
Removed from the RAM.
yes. So generally it waits when RTD computation is finished. The previous RTD will be removed from the RAM. This process continues until the action is completed. Hmm. Whenever action is performed, all RTDs are stored and computed. When action is performed, all RTDs are stored and computed. At Spark side. That is in Spark cluster machines. But the final result that we get by performing action is collected and stored in the client machine. What do you mean by client machine?
Local machine.
Client machine means the machine from where the job is submitted. During the flow execution, the RTD whose output is commonly used multiple flows will be persisted during the flow execution, right? The RTD whose output is commonly used by multiple flows will be persisted. Step 6. Finally, the RTD stored in the RAM.
We vanish.
Can be unpersisted if no longer required. Understood this, the steps in RTD's computation. Initially, all the RTDs are just declared. They'll be loaded and they'll be computed only when The action is performed one by the two, one by one RTDs only. They will be loaded and computed. Not all the RTDs will be loaded. If all the RTDs loaded, they can't be accommodated. That's why one by one they'll be loaded and computed. Okay. During the flow executions, RTD partitions will be loaded. RTD divided into partitions. Those partitions will be loaded into multiple ramps of multiple slave nodes, and here RTDs will be loaded sequentially. They will be executed sequentially, one after the another. Okay. So this is what next step. RTD persistence. RTD persistence means making the RTD available in the RAM. Even though its next RTD is ready. Advantage. What is the advantage of RTD persistence? Provides output. Provides its outputs. Many other flows. Provides its output to many other flows. No need to re-execute. No need to re-execute the flow. No need to re-execute the flow. So there are many steps you need to follow in this RTD's persistence. Steps in RTD persistence. Steps in RTD persistence. First step you know already. The RTD whose output commonly used by multiple flows need to be persisted. The RTD whose output is commonly used by multiple flows need to be persisted. For persisting an RTD, at least one flow should be executed.
Persisted for
Persisting
persisting
an RTD, at least one flow should be executed.
based on
Then second flow, third flows can be using that persist directly. Okay. We need to persist the RTD. We need to persist the RTD before action is completed, before action is performed. We need to persist the RTD before action is performed. Here I'm writing a note in this. RTD unpersist happens immediately. RTD unpersist happens immediately. That is immediately. They get removed. RTD persist. RTD persist won't happen immediately. Won't happen immediately. They won't happen immediately. RTD unpersist happens immediately. Immediately they get removed, but RTD persist won't happen immediately. When a RTD is persisted, anyone? When a RTD is persisted, when first time the RTD gets loaded, when first time the RTD gets loaded, it gets persisted. When first time the RTD gets loaded, it gets persisted. So RTD persistence won't happen immediately. Unpersistent happens immediately. So we need to persist the RTD before action is performed. RTDs will be persisted when first time they are loaded, first time they are loaded into RAM and computed. Even though the persist option is specified in the later steps. Even though the persist option is specified in the later steps. Methods to persistent RTD. RTD.persist, RTD.catch. Now, example, check this one example, right? I'm taking this flow. The same flow I'm copy pasting. RTD1, RTD2, RTD3, RTD4, RTD5. After RTD5, observe carefully here, try to respond everyone. RTD1, RTD2, 3, 4, 5. After RTD5, can I say RTD3 dot persist? Is it valid? Everyone try to answer.
Yes, sir.
After
No.
Before action we are saying, no? I think.
No.
No, sir. Because RDD3 is completed when RDD4 is executing. The time RDD3 will be removed, right?
everyone try to answer. Try to give your responses. Valid or invalid? Try to say valid or invalid.
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 Invalid, sir.
How these RTD computations you already know, right? When RTD2 is ready, RTD1 gets removed. When RTD3 is ready, 2 gets removed. When RTD4 is ready, RTD3 gets removed. When RTD5 is ready, 4 gets removed. Now you are saying RTD that persists. Will it be persisted or not?
No.
No, it won't be persisted.
Observe this flow execution. The output RTD3 will be persisted. RTD3 will be persisted. Yes. Even though you go after RTD5 also, it will be persisted. Because the flow execution. So here, 1 second there. Before I go with the, okay. Wherever you specify the persist option, wherever you specify the persist option, after R3 you are specifying after R4 or R5, wherever you specify the persist option, the RTD3 will be persisted. RTD3 will be persisted. When first time it is loaded and computed. . when we say RTD 5 dot collect here, whenever we say RTD 5 dot collect, whenever we say RTD 5 dot collect, from where it has to start the flow. From where it has to start its flow. So it checks. So it checks RTD5 input. RTD5 input is RTD4, and RTD4 input is RTD3. RTD3 input is RTD2. RTD2 input is RTD1. Which here you are giving RTD1 to, generally you will give some any name you will be given. So RTD2 input is R1. During this checking process, during this checking process from the bottom, during this checking process from the bottom to top, it will also come across, what is that? It will also come across which RTDs, which RTDs need to be persisted. Now, when loading from the first RTD, when loading from the first RTD, it persists the required ones when first time they are loaded. Understood now? Hello? Everyone, understood this? See, RTD5 dot collect means, if then it will come from the bottom onwards, it is going to come to the start from where it has to start from. If any RTD available in the RAM, from there it will start. Otherwise, so during this checking from the bottom to the top, it will come across those the instructions given, right? Which RTDs you need to persist during this flow execution. So it will come across all those. When first time when one by one RTD is loaded, it will persist those. Means here, observe. The flow execution is first R1 RTD1 loads. Okay, it's think that it is loaded and computed. Loaded and computed. RTD2. RTD2 loaded, computed. Will be removed from the RAM. RTD3 loaded, computed. When first time it is loaded, computed, and persisted immediately. Persisted immediately. Wherever you give the persist options, but before the action only it has to be. Any RTD, if you want to persist, when first time it is loaded only, it has to be persisted. Once it is loaded, again you cannot go back and persist it. RTD2 will be removed. Loaded and computed. R3 will be RTD3 will be available. RTD3 won't be removed. RTD3 won't be removed. RTD5. RTD4 gets removed. When action is completed, then RTD5 also removed. Now only RTD3. Am I audible to all everyone? Yes. So this is RTD computation, RTD persistence. So whenever the RTD first time loads only, it will be persisted. So what is that persistence here? RTDs, see the steps in RTD persistence. RTDs will be persisted when first time they are loaded into RAM, even though the persist option is specified in the later steps. For examples, you see. Observe these examples and try to respond. Flow 1. Observe this flow 1. R1 means RTD1. Okay, it got created by performing some operation. R2 got created from R1 by performing some operation. R3 equal to R2 dot. From R2, R3 got created. From R3 got created. From R5, R4 dot. R5 dot collector. R5 dot collector. So here after R3 itself only I'm giving the persist option. R3 will be persisted. Okay. So immediately after R3 only I'm giving this persist option. But see this flow 2. Observe this flow 2. Observe this flow 2. I want to give this persist option. After R4 I will give. After R4, will it be persisted or not? I am saying after R4 I am saying R3 dot persist. Will this R3 be, everyone try to respond. Will it be persisted or not, R3?
Yes, sir.
No, sir.
Everyone
Yes,
try
sir.
to respond.
Yes, sir. Proceed.
It will be persisted.
Will be persisted, right? Because until this action execution is done, when R3 gets loaded, it will be persisted. When it checks when R5 input is R4, R4 input is R3, R3 input is, during the checking process, will come to know which order it is to be persisted. When R3 is loaded for the first time, it persists. R3 will be persisted. Observe this flow 3. Flow 3 you observe. R3 dot persist I'll give after R5. It will be persisted, right? After R5 also, if you are saying before action only. In all the cases, wherever you specify the persist option, in all the above flows, wherever you specify, persist option, wherever you specify the persist option, the RTD3 will be persisted. Only when first time it is loaded and computed. Now observe this flow 4. Observe this flow 4. Flow 4. After this R5 dot collect, I'm giving this persist option. Will it be persisted? After this action, try to say no. Everyone.
It won't. It will
Whenever this action is performed, it will check okay. In this way it
Will not
goes.
be persisted.
Once and R1, R2, R3, R4, R5. When the R5 is execution, R5 also removed. When this total execution is completed only, it will go to the next one. By the time it goes to this, right, all the RTDs are removed from the RAM. No RTD in the RAM. Now you are trying to persist the RTD which is not available now. Error you get, right? So here just R3 won't be persisted, right? Everyone try to give a responses. R3 dot persist. Here R3 won't be persisted. R3 won't be persisted. R3 won't be persisted because when action execution is completed, when action execution is completed, we are trying to persist. But by the time no RTD is in the RAM, but by the time no RTD is in the RAM, understood? After this, up from here to here, everything executes. Until then, it won't go to that next step. But see here, if you want to persist an RTD, here we have seen clearly. For persisting an RTD, when you need to persist the RTD before the action is performed, before the action only it has to be. After the action means it cannot. Observe this next flow. Observe next flow 5. A question. Can we persist two RTDs? Can we persist two RTDs in a flow? Can we persist two RTDs in a flow?
Yes, sir.
Here after R5, can I say R2 dot persist, R3 dot persist. Will be persisted. Before action only you persisted it, then both will be persisted. Both will be persisted means both will be available in the RAM. Both will be available in the RAM. Now observe this flow 6. This flow 5 is similar to this flow 6. This R2 dot persist. After R2 I am giving. R3 dot persist. After R3 I am giving. In the above flows, flow 5 and flow 6. As follows. The above flows, right? Flow 5 and flow 6, the execution is as follows. First it checks. First it checks like. First it checks like R35 input is like. During this checking process, it comes to know that RTD2 and RTD3 need to be persisted. Need to be persisted. The flow is, see the flow is, check this flow, this one. I am copying the same. RTD1 loaded and computed. RTD2 loaded, computed and persisted immediately. Persisted immediately. Now RTD1 will be removed from the RAM. RTD3 loaded, computed, persisted, even though the persist option is RTD3, RTD2 won't be removed. won't be removed. RTD4 loaded computed. RTD3 won't be removed. RTD5 loaded computed will be removed. Now, when action is completed, RTD5 also removed. Now, RTD2 and 3, RTD2 and RTD2 and RTD3 remains in the RAM. Now observe this flow and try to respond, everyone. Observe this flow and try to respond. Flow 7. Okay. Observe this flow, right? Now, R3 dot collect, I will say here, R3 dot collect. R3 dot collect, I will say. After R3 dot collect, I'll say R3 dot persist.
Will not be persisted.
So R3 dot persist means here R3 will be persisted or won't be persisted? Everyone.
Won't
It
be
won't be
persisted.
R3 is not persisted. The flow executes from R1 to R3. Here, whenever I say collect here, what happens in this case? Will the flow starts from R3 or R5, R1?
Hmm.
The flow execution will means the flow will be from R1 to R5 or R3 to
R3 to R5.
R3 to R5. Where is that R3? Is it available in the RAM?
No.
If R3 is present in the RAM, then it will start from R3. But R3 is not in the RAM, right?
Yes.
It's not persisted. So from where it starts?
Again R1.
Here, as no RTD, as no RTD in the RAM, the flow starts from R1 to R5. The flow starts from R1 to R5.
So before that R5 dot collect, R3 dot persist, where does that get the value from?
Which one? This one.
Hmm.
Okay. Sorry. This is not there actually. Not there. There is not there. Only one persist. Okay.
Sir, it will be like infinite loop, right, sir? It won't be executed R3, R5, R4, no? Because next time, when it is comes to R5, again start from R1 and R2. R3 collect and R3 persist. So again, it won't it will be removed, right?
See, this is one first time I'm submitting two tasks. One is R3 dot collect, second one is R5 dot collect. Two tasks, two different tasks.
Yes,
Whenever
sir.
I say R3 dot collect, from R1 to R3 it will collect and to R3 won't be persist. Whenever I say R5 dot collect separately, the flow starts from R1 because R3 not available. In the before task, R3 is not persisted in the RAM in R3 dot collect. If R3 dot collect, if R3 was persisted, then in R5 dot collect, because the flow can start from R3 to R5. Now R5 dot collect is a separate one. Two persons, they are submitting R3 dot collect and R5 dot collect. For both, the starts from R1 or try to say one person saying R3 dot collect, another person saying R5 dot collect for this flow. For both of them, will it start from R1 or from R3?
R1.
Sir, for first
R1.
person it will start from R1, and for second person it will start from R3, no?
No,
Ah.
second also it will start from R1 because dot collect will remove everything from the RAM.
Sir, in that case, both are executing
Second flow, whenever you say
separately.
R5 dot collect, we'll check R5 input is R4, R4 input is R3. R3 is it available in the RAM?
No,
In the first flow, did it persist? No, right? In the first flow, if that R3 dot persist is before that collect, and if it is persisted means second task can reuse that for R3 to R5. R3 remains in the RAM if it is persisted. If it's not persisted, nothing in the RAM. The flow has to start from the beginning, from R1 to R5.
Got it, sir. So in that case, both are executing independently, right, sir? So there is no dependency.
No.
It's like a thread based.
Yes. It doesn't mean that from R3, R4 should be derived. R4 got derived from R2, you can say. Here, just these are the names R1, R2, R3. You can give any names. It doesn't mean that they should be in order R1, R2, R3. You can give any names.
Okay, sir.
From R2, R4 got generated. R4 equal to R2 dot, I can say, not only R3. From R2 it got.
Yes, sir.
1 second. I'll forward the notes up to here. 1 second. What all we discussed. 1 second. Just hold on for a second. Just a second. Just a second. Yes. Mm, Download that files, right, everyone? Yes, into one folder. Download all those files, everyone. Yes. Okay, check this out. PySpark introduction, PySpark RTDs, RTD computation, 3 diagrams, steps in RTD computation, RTD persistence. So this 8 as you can see that you can check it in that chart. You can download from that chart, right? Zoom chart. Everyone, 8 documents, totally 8.
We didn't got, sir.
Didn't get?
Mhm.
Everyone try to respond. Have you got or not? In the Zoom chart.
Sir, get it. It's not possible. You can share the folder directly.
In the Zoom chart, you didn't get.
We chat disconnected at the time. I didn't get now.
You can see in the Zoom chat. Some 8. 1 second. Control A. Copy. PySpark notes. I'm zipping it. Extract zip file, compressed file. Now let's check in the Zoom once again. Can you see a zip file now? PySpark notes.zip. Got now? PySpark notes.zip. Everyone, hello. Try to
Yes, sir.
respond in the Zoom chat.
Yes, sir. We are able to do.
Okay, check with this, right? Yes.
Sir, I'm attending from mobile. Maybe that is the reason. I don't know, but I'm not getting.
In the Zoom chart, you can see, right? To everyone, in the Zoom chart, you can see. Okay. Okay, fine. So tomorrow the class at 7. So you can follow the same link. So see that the videos, if you got enrolled, you will be getting that to your Google Drive. And from, okay. Fine.
Sir,
Tomorrow
can you share it in the WhatsApp group?
Tomorrow I'll be discussing about fault tolerance in Spark, right? Fault tolerance in the Spark. How this fault tolerance model is implemented using this Spark, and persistence options means memory only, memory and disk only, memory only, right? Yes. So yes, still if you have anyone who are attending only for PySpark, right? If you are not enrolled, try to enroll for getting the videos and the notes, right? And getting added to the WhatsApp group, right? Fine.
Sir, can you share it in WhatsApp group? Because I'm not getting in the chat.
I'll forward it.
Okay,
I'll
thank
forward
you.
Tomorrow,
Sir,
tomorrow,
do you have a Hadoop
tomorrow,
club, sir? No?
Tomorrow also you can attend same time using the same link, right? Same time and using the same link for tomorrow also. It's 7 o'clock tomorrow. Follow the same link for attending this. Yes. So I'm stopping for now. We'll continue.
Sir, do you have
Are,
Hadoop class
sir,
now,
are we
sir?
going to have Hive class?
Yes. It starts in 5 minutes. Those who are attending Hive, right? Just join in 5 minutes. Hadoop class who are attending Hadoop.
Okay, sir.